Wacha intro ya kwanza nichachishe. My talk boss, today we are talking about three-phase power distribution. Like you can see here, we have these three phases, and definitely very, very important because we will be discussing about how the phases are actually working. This is in a power distribution. The phases are 120 out of phase with each other. When it comes to a single phase distribution, my top boss, this is a very simple one. It is actually 50 Hz or 60 Hz. That means 50 cycles per second, on and off repeatedly. And after that, we will also be discussing about one important thing about three-phase. This is three-phase loads. So for industrial application, this is what I refer to as a motor, which is a three-phase, or a load that is three-phase. And also we will be talking about a single-phase power distribution. Top bosses, are you ready for our today's session? I can see that we are 7 of us in the stream, and I'm looking forward for more. This is John Gatehi, and this is definitely Top Heights Electricals and Electricians. Today, my top boss, let us engage further. This stream is an introduction to our three-phase coverage, where we'll be talking more when it comes to three-phase power distribution as well as three-phase loads. In our today's stream, my top boss, let us talk about these phases. In other countries, you find that we have the red phase, the yellow phase, and we have the blue phase. That is the case in my country. In other countries, we have different colors. So ensure that you equip yourself with that knowledge because it is definitely necessary. For the case of this diagram representation here, we have L1, L2, and L3. Remember, these phases are usually in sequence because we have the first phase, the second phase, and definitely the third phase. My top boss, in the comment section, let me know in your country, what is the color code for the first phase, the second phase, and the third phase in the comment section. Yeah. So top bosses, in what country are you in, and what are the color codes that you use for the first phase, the second phase, and the third phase, making it three-phase power distribution? What an incredible day today that we are talking about this. You will learn a lot about this power distribution. In an electrical power supply system, this is normally the case, especially when we talk about the national electricity grid. Other top bosses were referring to it as the utility supply. The same thing if you are in Kenya, that is Kenya Power. And in other countries, I don't know what you refer to your power supply. Now, when we talk about three-phase, we have three phases that are normally generated, and when we talk about this from the transformer, we have the secondary coil, which gives this output in terms of these phases, my top boss. So we will have the first phase, the second phase, and the third phase. There is something that is very important when it comes to the transformer, that is the neutral, especially at the secondary. The secondary is definitely the output coil of the transformer. So at the transformer, we usually have the star. Okay, there I made a mistake, but you normally have the delta and star. So delta, star connection type at the transformer. The primary windings are on a delta connection, and briefly we are going to talk about that in a short while, and then we will also draw the star representation and also come to see how the neutral is created from that setup. Top boss, if you're getting value out of our today's stream, smash the like button. Now, from the transformer, let's talk about the generation, because we normally have power that is generated at the substation and then it is stepped up by the transformer for transmission. Power is transmitted at higher voltages to minimize on the losses along the grid or along the transmission lines. So when the voltage is high, and this is for the AC distribution system, when the power is high, then it means that the resistance will be low, and that is the case here. So at the generation point, the power is stepped up. In many cases, you find up to 132 kilovolts kV, and then it is distributed to a substation, which then steps the power down. All right. So in most cases, you find that the power that is coming to our transformers for domestic or industrial use, you find that it is usually 11,000 or even 33,000. That is still in three phase. Now, in that transmission, you find that from the substation or from the generation all the way to the substation so that it can be stepped up, those are delta connection, because a star will definitely give a star will give a center point, and this center point is where we get a neutral. For large power transmission, where the power is to be transmitted to a substation, we don't require the center point or the neutral. All right. So it will travel in three phases only, or in many cases you have seen that this power distribution is in three conductors. Top boss. Three conductors for red phase, the first phase, then yellow phase, and then the third phase is blue phase, at least for my country, Kenya, my beautiful country. And so it will travel in these phases. What we have is usually the red phase, and then the yellow phase, and then we have the blue phase. Now notice this. At any given point, when this is up, the other phase is down. And then when this is up, the other phase are meeting at this point. Now remember, AC travels back and forth. So that is the reason why we have the name alternating current, meaning AC. So in that scenario, you find that power is up. One wave is up, the other, and then the next wave is down. All right. And so the good thing about AC transmission, you find that there's no point where, like in a single phase, it will be at this point right here. All right. So there's no compensation on this side or this part of the wave at this point. So for three phase, this is what happens. And then when it comes to single phase power distribution, we only have two lines. We have the line or the phase, and then we have the neutral. Now, the neutral acts as a return path for that phase so that it can complete a circuit. When power travels from the generator or from the transformer, it will go all the way to an appliance or to a load and then back. That is how it completes a circuit. But when it comes to a three-phase distribution, you find that if we have three-phase loads on this point, then there is no return path. But what we have is these waves, the three waves, whereby the load that is here, which is represented here, which is a motor, has the provision for all these phases. There is no neutral. When it comes to this motor, the DC motor, it will be fed with two conductors. the phase and the neutral. In many cases, you find that a capacitor is required for this so that there can be that assured rotation that is through, so that when it gets to 180 for it to achieve 360, then it has to be compensated by a capacitor. That is a topic for another day. My top boss will talk about it, but I would like to talk about the connection that is at the transformer level so that we can discuss about the star delta or the delta star, right? So we have, allow me to use this tape right here. I have a top boss that is assisting me here, very dedicated. Can you top bosses guess who this top boss is? The one and the only, of course, Margaret. Very hardworking, very intelligent. Yeah. So my top boss, when it comes to the transformers, we want to ensure that we understand about the internal of the transformer. In school, we were just taught about the theory aspect of it, but we also want to understand what happens internally in terms of the power distribution. So we have, this is a delta connection, goes like that. A delta, we might, oh damn, there's a, yeah, there's that there, then there's this, and oh, I'm really forgetting about these coils right there. So we have this, and then for power distribution, we can have a replica of this in the secondary of a transformer, so that that indicates that indeed that is a step-up transformer. We can go ahead and demonstrate it. Isn't it, Margaret? We can have a distribution or a demonstration for delta delta, so that we can demonstrate to people. Margaret, your pen is failing me. Maybe you might need to supply me with a red one. Supplier is here with us. Yes. So this is at the secondary, and then this is at the primary. Now, you might think that these are different sizes, but I hope you understand what it definitely means. All right. Thank you, Margaret. So this is at the primary. Sorry about that. This is at the primary. We can definitely use something different, isn't it, Margaret? What do you think? Oh, God damn it. Now this one is just putting me to shame. So if this is the primary, we can use a different mark for secondary. So at the primary, we have this winding that is right here. All right. Awesome. Thank you. Thank you so much. So we have the primary windings and we have the secondary. All right. Good. So at the primary is where now the power is fed from the distribution system. It could even be the generator. Once power is fed at this point, at the secondary, through induction, we then have the output that is fed to the national grid distribution system. Now, from there, that is when we now have the transformer, the local transformer. We can as well use another paper to demonstrate that. Top bosses, thank you so much for joining in this stream. And if you will be watching this on a record mode or a repeat mode, I will also appreciate when you smash that like button to show that you are getting value. Let me know where you're streaming from, my top boss. In what country are you in? So now that we have discussed about the primary winding at the distribution level, let us talk about at the point where it is stepped down, all right? So at the local transformer, of course, the transformer that is serving you with power, which is AC, this is what we get, right? So this is the primary winding. Still, power dropping to this transformer could be 11 kV or 33 kV. This is in AC, 11,000 volts, my top boss. That is heavy, heavy power distribution, 11,033 to this transformer. Now, the purpose of this transformer, it is referred to as a step-down transformer. And in this type of connection, I want to know whether you are keen in this lesson, my top boss, and you tell me what type of connection this is. I think I've made a mistake right there. Damn. All right. For this case, if let's say, forgive me. Let me do this. This is this type of connection. And then we also have this winding right here. You're already getting the picture what type of connection this is. And then we have this one right here. Top boss, what is this connection? Forget about this. I hope you do. Forget about this one because it can bring some confusion. So this is the primary. This is the secondary winding. What type of connection is this when it comes to the transformer wiring or transformer configuration? Do we have any answers right here, Margaret, concerning the type of connection which this one is? That is syntax. So is it delta from the primary, or he has just said delta? All right, he's right, because I'm very sure he's referring to this section right here. Yeah, but now the question is the combination of this winding and this winding. What are we referring to this connection right here? Anyone who has answered for the entire distribution? Mm-hmm. Delta star. Perfect. Who is he? Patton Munyiri. So that is P A double T O N. Patton has gotten it. Thank you so much. So this one is, you said delta star. Yeah. Okay. Delta star. Delta star connection. What is unique about this connection, my top boss, is that we get this type of connection at the center. All right. So this type of connection is very important simply because we get a neutral, a return path. So if we have the three phases, let me hope that these pens will not disappoint. If we have the three phases, we have that one. We can as well have that one. And then last but not least, of course, without saying, we can have this one. So this is the neutral. All right. So let me just give that so that you can know that this is diagram 1 representation. This is diagram 2. And this is not in any way supposed to reflect what we have here. This is the output from a star connection or a Y connection. Y in this writing right there. Y connection. Delta connection. All right. Where did the name Y come from? Delta come from. All right. So assuming that this is the first phase, let me say this is the red phase, this is the yellow phase. Sorry, I did that with a blue pen. And then we have the blue phase, at least for a country, that is the configuration. This is from the transformer. right? So these conductors are usually in this manner. So the one that is at the topmost is the first one, the first phase. And the second is the second phase. And then the third is the third phase, which is blue for our case. So in other countries, like the USA, you find that this is T1, T2, T3, all right? For us, we normally refer to as the first phase, the second phase, and the third phase, or we normally put it as L1, L2, and L3. The last one remains as the neutral. Very important. When it comes to single phase power distribution, very important, assuming we are tapping from the three-phase transformer, because that is very, very important. This is what I learned my top boss. So let us assume this is L and then this is N. So what we are definitely implying is that this one is the line or the phase, all right, or live, if you may like. This is the neutral or the return. Now, for this three-phase power distribution, assuming we want to tap a single phase from here, let's say we have a three-phase transformer. This happens especially in town setup or where there are industries. Of course, in other industries, you'll find that they will have their own transformer, which is in that building. They will have a supply of a bigger transformer as compared to what we normally have for domestic use, my top boss. So in the industrial setup, you find that because they need a three-phase power distribution. And in many cases, you'll find that there are so many motors, there are so many loads. So they will be supplied directly with an 11 kV transformer or a 33 kV, sorry, with an 11 or 33 kV power distribution system. And they will have their own transformer. In many cases, you find that they will have a ground mounted transformer or a GMT. And then from there, depending on the loads, again, the size of the transformer is dictated by the size of the load that that transformer is supplying power to. All right. But in the normal setup where we have the domestic setup, there are homes that require three-phase power distribution. Could it be homes? Could it be houses? Commercial buildings, to be specific, will require three-phase power distribution. When you get to those commercial buildings, is there any three-phase appliance such as a motor? Many cases you find that none is there. But you'd ask, why is it that those units, the homes, the houses, use single phase and yet we supply three phase to such buildings? Have you ever asked yourself, why not have a single phase drop to an apartment? What is the answer? Top bosses. Now, the answer lies in power distribution, and very importantly is phase balancing. But before we even go to phase balancing, remember in that case, for instance, if we have a building, here's the building. Margaret, can people see my building here? Nice. Now, careful you don't choke. If this is the building and we have the ground floor, first floor, second floor, third floor, fourth floor, and fifth floor, and rooftop. Yes? So we have several units here. And then we also have the underground right here, or what my top bosses in America refer to as basement. If they have basement, you find that this is a parking area. All right. So there are lights that are here. The lighting system will definitely depend on a single phase power distribution. So now at the meter board of this commercial apartment, could be it is at the ground floor or it could be at first floor, but in most cases it is ground floor. Now you find that there are energy meters here, several energy meters. All these energy meters are usually single phase, all right? And then this board carries each and every meter that feeds power to all of these houses. Could be in the first floor, we have 10 units. All right. Second floor, we have 7 units. Third floor, 10. Fourth, and so on and so forth. So what will be happening here, the total number of energy meters, this reflects the total number of homes or houses in that apartment, will be calculated or will be determined, assuming that total is 30 houses. Okay, that doesn't make sense. Since I said 10 here, 7, 10 here. Let's go with how many houses in that apartment, Margaret? Total. 30 seems to be lesser. How many houses in this apartment? And we go with 45 houses. 50? Good. 50. That is Margaret saying that. 50, which makes sense because from here, we can probably have 5, 7, and all that. So 50. And we have 3 phase. Assuming that these houses have loads that are almost the same. You find that in a residential house, you find that there's a kitchen, there's a bedroom, there's a sitting room. So the needs are almost the same for all these units because the appliances that are used here are usually home appliances. Now what we have is definitely single phase. All right. Margaret, did just power go on us? Yeah. We shall survive like that. Top bosses, it is because you are not liking this stream. That is why the power has just gone. Show some love for our work. So if we have these units and we have 50 units, 50 houses, then we will divide that by 3. All right. So 50 divided by 3, what is that? On average, that will be around mathematics, around 16 units per phase, isn't it, Margaret? Margaret is laughing at me. Around 16 units, all right? So 15 can be dedicated to a certain circuit or a certain phase, all right? So the installer there can decide for all the energy meters, the first energy meters, like let's say the ones that are in the ground floor, we can have 15 of them on that phase, others which will be of course on first floor. Then the second phase could be 15 as well. The third phase could be 15. So we have, that is 45, and then we are remaining with 5 houses that are not yet connected. So the technician can decide to add 2 to this phase, add 2 to this phase, and then add 1 to this phase, making it a total of 50 connections balancing the phase. That is where now load balancing applies in this case. All right. There are other cases whereby you find that in that commercial apartment or that commercial setup, we have what we refer to as pumps, or a lift, which uses a motor. This motor has a 3-phase motor. Now, what the technician will do, of course, in that case, is to tap from these phases, all of them. The neutral in that case will not be required, because remember, when it comes to 3-phase machines, 3-phase motors, you don't require a neutral. All right. Okay. So shoot your questions, my top bosses. This is a live stream. Each 2-phase will have 17, the rest will have 16. That is from Syntax Ben. Thank you. Thank you so much, Syntax Ben. I really do appreciate that feedback. Keep it up, dears. That is a comment from Syntax Steel. Appreciating Margaret in very, very high regard. Thank you so much for recognizing her. She's doing the most here. Yes, so Syntax has told us we can have, is it 16 or 17? 17. And that is basically about power distribution. Why is it important for an electrician who is conducting this kind of work in this setup to ensure that they balance. Why? Now, there's this interesting aspect that can occur. For instance, if there is a cable, this is a distribution cable, and this distribution cable is a three-phase. If the electrician fails to balance the phases, one phase will be overloaded. If the phase is overloaded, it will start to overheat. Cases where you find that there is a problem with that, you will find that when it starts overheating, it puts pressure on the insulation of the conductor itself or the cable itself, meaning that that cable will be compromised. Another downside to that, not balancing the loads, is that you'll find that any protective device that is connected to that load before it is supplied to energy meters will start to arc or to overheat. Let's take an example of a cutout. So for these residential areas, you find that in this distribution board, you'll find that there are three cutouts. Okay, three cutouts. So 1, 2, 3, and then the neutral goes direct to what we refer to as a neutral bus bar. Top bosses. Why is a neutral not connected to a switch? Because if a neutral is disconnected in the presence of a phase, that will result into a floating neutral or a surge. If you ever break a neutral and the lines are on, that is dangerous. That is the worst mistake that any electrician can make. Before you break a neutral, ensure that you break the phase connection. Why? So that you don't create a surge. If you want to work on a neutral, ensure that all the lives or all the phases are turned off. If it is a cutout, ensure that you disconnect them, all right? Or if you have that MCCB where you have four pole, a four pole means you have the first phase, the second phase, the third phase, as well as the neutral. So that means if you switch it off, you have not only switched off the phases, but the neutral is disconnected. The neutral is always disconnected together with the phases, all right? Or if not so, first disconnect the phases, then lastly disconnect the neutral so that you don't create a surge. In industries, in places where you have a surge, which is especially internal, this occurs simply because you have a neutral that is broken, therefore resulting to a surge that is internal. And that surge can lead to rise in voltages, which can damage appliances. So if one day you will be called to check why appliances in a certain office are blowing up, or they are burning, or they are frying, just know that the first suspect is a neutral. Is there a loose neutral somewhere, especially at the distribution board or at the common places such as the consumer unit or at the board where there are several connections? Now, problems that can occur in this type of connection is when people fail to use the bus bar. Very important to my top bosses. If you don't use the correct bus bar, it means that the connections at the neutral will be loose. In a three-phase connection, why is the neutral very, very important? Remember, each and every of these phases, for instance, we have been told by our top boss, if we can use one phase supplying 17 meters or energy meters or customers, it means that for those 17, they are relying on this single path, which is the neutral. If this path is compromised, all the 17 energy meters or accounts or houses that are connected to this phase will definitely experience a surge. All right. So as an electrician, always ensure that the neutral is never ever compromised at any given point. Any questions, my top boss? Margaret, do we have anyone with a question? Not yet. All right. So my top boss, if you have a question, just let me know in the comment section and we will be ready to assist. From there, my top bosses, we go to something that is very, very important: industrial connection for three-phase motors. A motor, you will realize that it is also uh, made in a way that it has three windings: 1, 2, 3. What is very important about this three-phase motor, my top boss? These windings are 120 out of phase with each other, so that at this point where we were talking about the connection right here, where these phases come in out of phases with each other, if at this point we have this phase energized, or the coils are supplied with current, it means that the rotor will move. All right. And then at this point here, if at all we don't have current that is flowing, assuming it is at this lower point here, let me just expose that point before we can go back to that demonstration that I had drawn earlier. All right. So at this point, we have these two phases engaging the motor. So maybe it is 1 and 2. And then when it turns to this point number 3, we could be at this point here. And then that means that at this point, we also have some current that is flowing. Remember, this one will be meeting at this point. So that is 1 and 2. As 1 is going down, 2 is going up, and therefore it will ensure continuous rotation of that motor. Here is where electromagnetism works, or your knowledge in electromagnetic induction will really help you, because the current that is flowing in these windings will cause a motion to occur in the motor rotor. Does it make sense? Hizo mapepa kumbe kwa video zinakaa vibaya, zinakaa ni kama curtain za mshoshi. So do we have any comment that we need to look at, Maggie? Not yet. So are people enjoying the lesson? Yes, Ben is locked in. Locked in like never before. Thank you so much, Ben. We will also be talking about or demonstrating how the wiring is done. For today, we are discussing about that power distribution using pictorial elaborations. But again, my top boss, in the next video that we will be doing, we will go deeper and showcase the motors. We will even showcase the distribution at the meter board for this commercial setup, where we have talked about this power or load balancing that is at this point, so that we don't have other meters that are jacked on a single phase. We don't have very few meters on another phase. Now, in these buildings, you'll find that there is sometimes where there is a power outage in one floor, and then there is presence of power in other floors. And you may wonder what in the magic is happening right here. It is very simple. At the transformer, top bosses, we have the output that we have discussed about, and it is not alarming when this happens in a commercial building. At the transformer, we have this connection where we have the three phases. Now, we usually have the fuses at the exit of every phase, right? So assuming this is the L1, L2, and L3. If L2 blows up, this is the fuse at the transformer L2, and this is definitely the Y phase. It means that everyone that is connected to that phase will not have power because the fuse is blown, and that definitely transmits. I wanted to say translates to anyone connected to this phase whose fuse has blown to remain in darkness. All right. We have a question here, or is it a statement, Margaret? Yes. Read it for us.
The person is called Jesus.
Yeah.
Jesus Padilla.
Save us, please. We don't have power.
I would first like to say, great teaching,
Thank
my
you.
friend. My question is, would it be possible to show me how to make a three-phase generator? If possible, thank you.
A three-phase generator. How to make or how to repair?
How to make?
How to make. That means building it from scratch.
Yes.
Wow.
Possible.
Jesus, thank you so much for your question. I wish I was a creator, but I will try as much as possible and gather information and then share more about that. But an important aspect is to understand how power is induced into a current carrying conductor. Now, for that case, we normally have generators. These generators have actually motors, all right? So with motion fed to these motors is like we reverse psychology how transformers work or how motors work. And therefore, if we have magnets which are three phase, did he specifically say three phase or single phase? Three phase. So if we have magnets all aligned in 120 out of phase with each other, and then these magnets are turned by whatever means, especially for power distribution, we normally have these magnets in, like, let's say, waterways. That is why when we have power generated from water, we have a dam, and then water flows, which turns the turbines on. So the turbines will start rotating and therefore inducing current into a current carrying conductor. And that is how this will turn into this. Without the knowledge of electromagnetism, it might be a bit harder. But I'll make it simple for you, my top boss, top of the top, Jesus. What happens right here is that when there is motion from magnets or a magnetic field, if a magnetic field is moved, it creates an electrical flow in an adjacent current carrying conductor. All right. The same way happens in a motor situation, whereby if there is current that flows in a coil, which is a current carrying conductor, then it will definitely activate the electromagnets, and then they will start to move. And that is how motion will be created. So motion leads to electricity generation, and electricity generation leads to motion. We will talk more about that. Any other question?
No.
We continue, right? So allow us in our coming videos to share more when it comes to power generation, my top boss, Jesus. Now, we were talking about these fuses. Can you have a scenario whereby the entire building will be in total darkness? What can lead to that, top bosses? All right. So in a transformer distribution whereby it is, for instance, multi-purpose use, you find that it is in a commercial setup, a town, and so many people are dependent on that transformer for electricity supply. You'll find that these issues will mostly occur. The phase that is usually affected either has a loose connection at the fuse carrier, that is number one. A loose connection will lead to arcing. Arcing will lead to will lead to disconnection of that fuse or affecting the circuit operation. All right. Another thing is if the technicians from the power distribution system, for our case is Kenya Power, decide to, instead of using an 80 ampere fuse, they come with a 40 ampere fuse, which is half the required load. It means that every person that is connected to that distribution line, which is a Y, will always suffer power outages because the fuse will keep on blowing up. All right. Now, what will happen is that these people connected to that phase will always suffer. Another thing is at the point where we have these three-phase power distribution, and then we also, this happens again in towns or in urban settlements, you find that there's a common transformer, this one, and then along the way, before these phases, before this three-phase distribution gets to the three-phase customers, you find that there are single phase connections. Now, this company, again, the Kenya Power in your country, can decide to connect the red phase and the neutral all along that power line. That will definitely mean that this L1, the fuse that is connected to the red phase is overloaded. Right? So what they need to do is to have a system whereby they can be able to tell that we have connected several customers. For us here, technical terms, we have connected several loads. We have connected 100 houses to red phase. And yellow phase, green phase, okay. And yellow phase has 70 customers. But on blue phase, we have 120. It means that that phase will usually have issues because that one is an overload. What they need to do is to easen the load on this phase and decide to have 100 customers connected here and 90 customers connected here, so that we cancel that and we have 190 and 100. So that will mean that even the transformer itself will not be imbalanced. You know, when the secondary winding of a transformer is not balanced, it means that it will start overheating. There will be a lot of chaos in the transformer, bringing about issues. Yeah.
Then it says there will be an overload.
Then there will be an overload. Absolutely. And I agree with him, because if at all you connect so many customers to one phase, and these are three phases, feeding three-phase customers, even the three-phase customers will be affected, especially the ones connected to the phase that is overloaded. All right. How do you achieve a single phase connection? Like we have said, you just tap one of the phases under neutral, feed that single phase customer. All right. So that is how you connect a single phase from a three-phase distribution. Can you connect a customer who requires three-phase connectivity from a single phase? Remember, we can also have another power distribution where we have a single phase transformer, right? So taking these, all right, all right. So bear with me. We shall have a lot of diagrams here to, just be able to understand about the power distribution. So for this case, this is definitely Jesus. Thank you so much for showing up in our live stream. Now you see, by you showing up, the lights are back. Thank you so much, our top boss, Jesus. Continue watching our stream. You are indeed our savior. What an incredible time to be alive. Salute, salute. Yes, sir. So we go on, right, Margaret? This is three-phase distribution like we were talking about. For a single-phase distribution, can it also be tapped from a three-phase power distribution? This is a delta-delta connection. So if we have these 11,000 volts kV, all right? Now we want to connect single phase customers who are the majority here, especially in rural setups. What will happen is we will have a single phase transformer. These are usually pole mounted. So from this, we will tap a single cable right there and another one right there. It could be from yellow phase and blue phase, or blue phase and yellow phase. And then it will go all the way to a transformer whose windings are like these. All right. So that is what we'll have. And then we will have the secondary windings on this transformer. Notice that for this type of connection, we have two conductors or two lines, and then we have the two lines that are on the output. Okay. Now, my talk boss, for these transformer types here, we can have this giving an output which is 240 volts, meaning tapping from end to end, right? So that we can achieve 240 volts to supply to single phase customers who are in regions that require 240 volts or 220 volts. If we talk about our friends, top bosses from the USA, when it comes to the USA power distribution, it will be fed from the secondary, it will be fed from the primary, and then the center will be tapped so that it can give 120 volts AC output. So this is mostly used in the USA, whereby you can have the neutral, and then the center tapping will definitely be the line, all right, so that you can achieve the 120. Also in the USA, we have the connection whereby the customer will require 220 volts for appliances that require that kind of voltage. For instance, the dryers, the washers, and the likes. And then for the normal appliances, we can have 120 volts. This is common in USA and Canada. Any question, Margaret?
No, they are just saying let's celebrate for Jesus.
They're celebrating him.
Yeah.
They have also seen the effect of a light. Yeah, light is here, the light has come, Jesus is in the building. Thank you. So for the US customers who require voltage supply that is 240 or 220, then the transformer, which is right here represented by this diagram, will give a 220 volt, and then we will also have the center tap. So if these three lines are supplied to a customer in the US or in Canada, it means that if they tap from the center line, in most cases, this is black, all right? So this is a black, even in the consumer wiring, USRG consumer. For the USA, they have the power panel, electrical panel. Unasema? Boniface, welcome. Thank you so much for joining in, and I really do appreciate you. Thank you for your feedback. So they will have the black, and then for the neutral, they will have the white. If the circuit that they are using is 240, then that one will be in red color. So this one is neutral. This difference here is usually created at the transformer. So how many minutes are we into this stream? 53. Can we do like 1 hour, 5 minutes or something? Awesome. So we continue going, right? Incredible. So this is how the power will be distributed to achieve 240 and 120 volts for the USA homes. We have said that for the circuits that require 240, we have listed one of them being the dryer, and also if we have any machines or chargers. For instance, you want to charge your car, could be a Tesla, and you want to charge it at 420 volts. Right. There was an issue with the Wi-Fi. Restart. But then a load. Restart. Reload. Reload hapo juu. Exit full screen. Double click. Pale juu. tab hapa kando hapa. Yeah, good. Should be good. Oh, kule unaona hata network haiko. Nashangaa, I think ni vile hiyo net imeenda karudi. Wifi. We are back. Are we back? Someone is saying network problem. Hey, you guys call me sir. I feel like I'm a headmaster. Now, can someone confirm whether we are back, top bosses? We had a power outage and we are trying to recover. We are back in the building. Can someone confirm whether we are okay? Still having issues, right? Nice. We are back in the building like we never left. In fact, we never left, my top bosses. If anything, probably it is your network. But for us here, we're doing well because we have Jesus in the building. Incredible, incredible. Where were we? We were here talking about the US connectivity, and we have agreed that for that type of transformer, that is how it is tapped. Now, for us here in Kenya, what happens if we have this connection where we have 220? Most of the appliances going to these regions that have a power output which is 220 to 240 use that amount of voltage. Voltage is very important because, again, when it comes to current, current is determined by the load or the pull from the transformer or the source. Somebody is saying something, right? Who? Oh, lecturer. God damn. I need to apply in these big institutions. Do you guys think we should apply in Harvard? Margaret, what do you think about Harvard? Should I go to Harvard or KU? Harvard. KU. Thank you. KU is a bit chill. Incredible. Much respect to KU top bosses and our colleagues right there, not colleagues, comrades. All right. So in a power distribution where we have single phase that give an output of 240 volts in the distribution system, in many cases you find that they don't have the need to create 120 volts because that is their system, right? When we talk about 50 Hz and we talk about 60 Hz, what does this mean? That is a system where we have 50 cycles. Cycles, we talked about the cycles here, where if, let's say, we have this type of wave that is formed, and then this is T. So one cycle is what we refer to as Hz. So if we have 50 Hz per second, again, depending on the region. In our country, we use 50 Hz. In other countries, they use 60 Hz. This is USA and Canada. Correct me if I'm wrong on the comment section, but that is what I know. Now, when it comes to the connection where we require certain current, current is only determined by the power that is consumed by these appliances. Yeah. Ben is saying what? I gained more from you, my top note. That's why I appreciate being with you on this live streaming. Much love. Wow. Ben, right? Thank you so much, my top boss. I really do appreciate your feedback. Incredible. Thank you so much for that, Margaret. Now, those are cycles that we've talked about. And last but not least, on single phase transformer, we only have the output, which is a line and a neutral. So if someone wants to be connected to three phase, they will have to pay the utility company to have the power connected at this point, all right, and have these three conductors, assuming that this customer is residing in a place prestigious place in Kenya referred to as Wetevie, right? Or Wete in short. And then this single phase transformer is at this point, but the customer is ahead of these other connections and ahead of this transformer. What will happen? They will need to make an application so that these conductors are connected from this point all the way here. If there are only single phase connections here, then it means that it will not be of help, because for a three-phase connection, remember we require a delta connection. From the delta connection, we will achieve on the secondary a star connection, forming a delta star connection, which is right here. So the three conductors will be fed to the primary of the three-phase transformer, and then on the output where we have the Y connection, we will have the three phases, which is red phase, yellow phase, blue phase, and something extra which is very important, the neutral. All right, so that the customer will be supplied with that power. Let me just mention something that is very interesting in today's day and age, where we have a lot of people suffering from power outages. Now, at the beginning of the session, we were talking about a GMT, a ground mounted transformer. We talked about a customer who has their own transformer. In many cases, you find that they have their own control over the transformer. We have something popping up.
Dan, that is watching from Sandumiriu Power Station.
From
Sandumiriu
uh,
Power Station.
power station. Dan, are you working there? And does this lesson of today make sense? Ama ni story za jaba? Let us know if that is the case. I have talked to people and I've told them that before power is distributed, it has to be stepped up. So from the generation point, where if we have the power generated at Sondu Miriu, we learned that in school, and I've never visited. I need to visit there as a physicist. So it is stepped up from the generation point. Is it true that the power is stepped up for transmission? Yes.
There's a person saying, when PC learner, why don't we go above 3 phases? We can't get more power.
Or why don't we go above 3 phase? Oh, like we have 4 phase, 5 phase. Now, for that case, we don't have any invention that has come up where we require more than 3 phase load. You see, the power distribution, according to what I think, is dictated by what we use as humans. So, assuming that we require motion for our daily usage. So, in a building, we require a 3-phase motor to move that lift or elevator. If someone comes up with an innovation whereby the motor has to be supplied with 5 phases, then at that point, engineers will have to go back to the drawing board, such as mine, and then come up with a way to supply such loads. Remember, back in the days, we used to have direct current loads. Which one came first? Is it direct current loads or is it alternating current loads? Top boss, let me know in the comment section. Which one came first, or is that a silly question? Maybe they existed at the same time. All right. So if we have a 3-phase load, we definitely have a 3-phase max phases from the distribution system. Yeah. Any other question, Margaret?
That is saying, yes, it's true to reduce power loss.
It is true too?
It's true to reduce power loss.
Oh, I think he's talking about transmission, right? So essentially what we are talking about is at the point where the power is generated, it is stepped up for transmission, so that when it is transmitted at higher voltages, such as 132 kilovolts or even more, there's also there's another one I can't remember, but this one is stepped up before it is stepped down at the transformer, so that along between the generation point to the substation. It is usually a very long distance, so we reduce on the losses. Yeah.
He's done.
Yeah.
We also say
Mhm.
six-phase was suggested by General Electric, but dropped due to complexity.
Complexity, right? Yeah. Yeah, I think General, did he say General Motors?
General Electric.
Oh, General Electric, very big company in the world in terms of electrics. Now, I don't know where they were going with that, but imagine even the production and also the distribution. You will require 6 power lines or 6 conductors. 3 seem to be a lot of work, especially in developing countries, where you also require to ensure that these conductors are safe and these conductors do not cause any harm to the environment, to the humans. And what's more, how are you able to ensure that you can transmit this power without the failure, all right, or harming the distribution system itself? Yeah. Uh-huh. Somebody is saying, why are scientists searching HV, high voltage DC, after investing billions of dollars in three-phase AC power system? Um, I think it's all about control, but I'm not so sure about that because I've not come across that research. But nowadays, I believe that anything that is done in terms of research is to ensure that there is a lot of control, not really for scientific gains, but a lot of control for the humanity and also to lock some of the things that have been happening. At least that is what I know. But my top boss, I will do more research on that and then definitely come with a solution. So we are about to end this live stream, my top boss, so that we can share more of the information. But now today's recap, this is what we are talking about: the three-phase, understanding the three-phase as well as the single phase. The three-phase is 3 phases that travel at 120 degrees out of phase with each other. In many cases, you find that there is a delta-delta connectivity that gives this type of connection. Yeah. Margaret, you seem to have
No.
something. You're good? Right. How long have you been here?
16 minutes.
Nice, nice. Incredible. Top bosses, if you have a question, let me just know. So we have talked about the distribution, the production, transmission, and distribution of three-phase. We have talked about the single phase. That one comes very easy to understand. We have also talked about the loads. My top bosses, we have talked about the three-phase loads, the single comes to the distribution. When it comes to the wiring also of the building, ensure that if you're tapping from the three-phase connection, ensure that you balance. In many cases, you find that for the industrial connection, we have three-phase motors. Three-phase motors don't have the need for a neutral. So if this connection, and we'll also be doing the connection for three-phase motors. I know many of you have been requesting about the windings of the three-phase motors, the rewinding. We'll also be talking about that and see how these come to play when it comes to this three-phase motor, my top boss. We'll also be answering some of the questions that you might be having in your mind. What if one phase fails and it is connected to this motor? What happens to the speed of the motor? What happens to the sequence, the rotation of the motor? How is it affected? Will it stall, or will it move back and forth? Or those are some of the questions that people have. I also have them. Or will it actually get to a point where it is blown, the windings, all right? So we'll talk about that. If this single phase motor does not have a capacitor, what does a capacitor do? It compensates for the absence of that, you know, the connection that is supposed to, the weight is supposed to be at this point. So because we normally have the upper curve and the lower curve, if at all we have a capacitor right there, because it's a single phase, we will definitely compensate for that. Right.
Okay. Jamal had a question.
Yes.
But ishajibiwa.
Oh, somebody in the comment section has answered.
Yeah.
I think we can wind it up because of time, and then we will talk much more about that, isn't it? All right. So there's an extension right there. So I'm collecting any of the questions that you might have, but my talk boss, don't worry if you have a question or if you'll be watching this stream as a recorded version, feel free to give your feedback. It could be in terms of a thank you note, it could be in terms of a question that you have for us, and we will definitely be very, very honored to respond to it, my top bosses. All right. Incredible. So where are you streaming from, and what query do you have? That is some old schools things right here, Margaret. Yeah, you see that? That's good. Yeah. So if you have any queries, let me know, my top boss, in the comment section. And I will also appreciate if you tell me, especially when we talk about the first conductor on the distribution system for a three-phase, what color code do you go with in your region or in your country? Second color code for a three-phase conductor. Then the last but not least, what is the color? For our region, I know about the red phase, the yellow phase, which is at the middle, and then the blue phase, which is below. All right. If this distribution system is a three-phase at the secondary, then we have the neutral. And we have red, yellow, blue, and black. Yes.
One case is asking,
Mhm.
was can you do a practical on three-phase connection for us?
Yeah, sure. So when it comes to a practical, is it the power distribution, for instance, the transformers? I will do that. Is it the power distribution at the industrial setup or commercial buildings such as this one? I will definitely drop videos to do with that, and you will definitely learn a lot when it comes to that for sure.
Wilson is also saying,
Yeah.
make one of the rewinding motors.
He's saying?
Make a one
Yeah.
of the rewinding motors.
Ah, nice. So rewinding the motors, probably it could be the three-phase motors, these ones, or it could be the single phase. We will also tackle that when we will be talking about that. I believe that they will also love to see how the rewindings are done. And another important thing, especially for the three-phase motors, is the connection. Is it star delta, delta star, and all that? We'll talk about that in our coming streams or videos. Yeah.
Jamal is saying,
Mhm.
what if there is a power surge on three-phase? Does it affect all phases or just one?
If there's a power surge on three phase. Mm.
Does it affect all phases?
It depends on what the surge has hit, and especially is it the secondary or is it the primary. Now, if it is a transformer, if the power surge strikes on the secondary of that transformer, it means that it will be compromised because the output will have an issue. Again, remember, if the distribution system does not have the protective devices, for this case, allow me to use the word sufficient protective devices, then it means that it will be compromised in this manner. At the transformer level, we have the output, which is red YB. If it strikes on either, there is an issue there because that surge will travel all the way to the customer's loads or homes. Another issue is that if these strikes on the primary lines or the primary conductors that are feeding the transformer, especially for this case on the delta connection, we normally have something that is at the transformer that is referred to surge diverters. These surge diverters are connected and then they are earthed. So this is at the transformer level. So it is very rare to have such a case unless the earthing is compromised. Yes.
Ben is asking,
Mhm.
of course, I'd like to know the difference between delta star and star delta.
Yeah,
Correct.
the connection of the motors, right? Sawa sawa. We shall do that, and you will definitely appreciate how that connection will be done, and I will also be looking forward to have that moment with you. Either it is through a video or it is through our live stream. When we will get these machines, because they are very expensive to access them, we can have somewhere where we can go and ask for permission so that we can learn. Yeah, thank you so much for your time. Margaret, do you think it is time for us to end the show? It is? Okay. So my top bosses, that is a promise that I'm giving you. We shall have the lessons on the three-phase connection, the star, delta, and all that, and also the windings. We shall also be posting videos on the power distribution. All right. I hope you will learn a lot. And Maggie, you have something else? Yes.
Pattern is asking,
Pa?
pattern.
Pattern, eh?
If there is a surge, then can it be stopped by a critical?
No. If that surge travels especially through the secondary uh, conductors from the transformer, and then in your house you don't have a surge diverter, not a fridge guard, not an AVS 30. Those are just switches that monitor the voltages, all right, and especially at the point where the power is off. So they will allow voltage to flow in case the voltage is within a certain limit. Some, some of these fridge guards are blown by high voltages that come from the distribution system. These voltages can be from the lightning, or if one conductor is in contact with another conductor which is wrong connection. For instance, if you have a high tension power line which is supposed to be connected to the primary, getting in contact with a low voltage power line, it means that it will induce that voltage into the low voltage power line that is going to the customer, and that amount of voltage will travel to the customer's home, appliances, and definitely that voltage cannot be stopped by a fridge guard, TV guard, or an AVS 30, and it will lead to damage of their appliances. Right. Sawa sawa. Thank you so much, my top bosses, for tuning in. It was a great pleasure. We have really enjoyed learning about three-phase connection. We will be talking about more of three-phase connectivity, the motor windings in our subsequent bulletins. Wow, wow, bulletins. And also, we will be doing the practical connections, all right? Practical terminations, and also how to rewind this motor one-on-one. And I hope, my top bosses, you will learn a lot. Smash that like button if you have found value on our today's live stream today. And my top boss, let me also know where you have been watching me from. I will really appreciate. If you'll be watching this on a record version, I will also appreciate your input, and especially where you have learned from. My name is John Gatehi, and this is Top Heights Electricals and Electricians. Catch you in the next one.
Yeah, listen for Ben and comment.
Mm.
May you please remind me how to connect three phase to the cutters which were internet.
All right, we have done a video on that. Check it out on our YouTube channel. All right, end the stream.